Used a supercapacitor as the power source, a DC motor to spin a fan, and toy wheels to make it move. When the supercapacitor is charged, it powers the motor, which drives the fan to push air backward, propelling the car forward. This project is a fun way to explore how air thrust and stored energy create motion. Let me know your thoughts in the comments. Don't forget to like and share. This is a 2.7 volt 10 farad supercapacitor. Today I'm going to use it to power this DIY bell. But will it work? Let's find out. First, let's test it without charging. Nothing happens. Why? Because the supercapacitor isn't charged yet. So let's charge it up using a 3.7 volt battery. Just a few seconds should be enough. All right, now the supercapacitor is fully charged. Next, I'll insert both of its pins into the female cable connector of the DIY bell and turn on the switch. And look at that, it's working perfectly. But wait, something interesting just happened here. Remember, the supercapacitor was charged with just a few seconds of power, yet it's able to run the bell. So what's really going on? How is this possible? Think about it. Can you explain why this works? Let me know your thoughts in the comments. If you have numerous LEDs for your electronics projects and need to test whether they are functional before incorporating them into your designs, this LED tester is an ideal tool to ensure they will work properly. This is a police light strobe, the kind typically mounted on police vehicles, and I have successfully designed and built it as a DIY project. It replicates the flashing lights seen on police cars and can be a fun and educational project to try out. If you're interested in creating your own version, I've provided a detailed circuit diagram on sciencequizbook.com. Feel free to check it out and give it a try. Today I will guide you through the step-by-step process of properly connecting wires to a 2-pin plug, ensuring a safe and reliable electrical connection. This is a crucial skill for anyone who wants to repair or replace a plug for household appliances, chargers, or other electrical devices. But there's one critical step that many overlook. Without it, the connection could become loose or even unsafe. To prevent the cord from being accidentally pulled out, it's essential to use a cable tie clip or strain relief clamp for added security and durability. Let me know what you think about this idea in the comments. And don't forget to like this video if you found it interesting. Today in this video, I'm going to show you how to control the brightness of an LED using a 2-coulomb potentiometer. I've soldered the positive leg of the LED to the positive terminal of the battery. Next, the negative leg of the LED is connected to the middle pin of the potentiometer. Finally, I've soldered one of the side pins of the potentiometer to the negative terminal of the battery to complete the circuit. Now watch what happens when I rotate the potentiometer. As I turn it, the LED gradually gets brighter and dimmer. That's because the potentiometer is acting like a variable resistor, controlling the amount of electricity flowing through the LED. This is how dimmer switches work in real life. You can use this trick in many electronic projects. Let me know if you'd like to see more experiments like this. Today, I finally received the V-type supercapacitor I ordered. Let's unbox it and take a closer look. At first glance, it may seem small, but don't be fooled. It packs a punch. To get it ready, I'll charge it using a 6-volt battery for just a few seconds. This is a 1F 5.5 volt supercapacitor, compact in size but powerful in performance. And now it's fully charged. Time for the real test. I'll connect it to a 6-volt DC motor and see how it performs. System of multiple gears inside, rotating smoothly. These gears help in reducing speed while increasing torque, allowing the motor to drive components like oscillating louvers in an air cooler. If you enjoyed this teardown, make sure to like, share, and comment your thoughts. What other motors or gadgets should I explore next? Let me know in the comments. Hey everyone! Today, I built a simple electric project using a 3.7 volt. Don't forget to like, share, and comment with your thoughts.
Plus, with its solar-powered design, there's no need for wiring. Just set it up and let the sun do the work. I'll be testing this light in a detailed video soon, so stay tuned for that. But if you're interested in getting one right now, click the products button here to check it out. Make sure to like, share, and subscribe for more cool gadget showcases.
Today, I've built a powerful mini DC fan using a high-speed DC motor typically found in drones and a supercapacitor as the power source. Drone motors are known for their impressive speed and efficiency, making this fan surprisingly strong for its size. The supercapacitor I've used can store and release energy much faster than a regular battery, which gives the fan a quick and powerful start. Now let's test it out. This is an LED. Now let's connect it to a 3.7 volt battery through a 100 ohm resistor. As we complete the circuit, the LED lights up, indicating that the current is flowing in the correct direction. Now let's reverse the polarity by swapping the battery connections. Since LEDs are diodes, they block current when reverse biased, so the LED does not light up. To solve this issue and allow the LED to work regardless of polarity, we'll use a bridge rectifier. Now we reconnect the battery and the LED lights up. If we swap the battery terminals again, the LED still works, demonstrating how the bridge rectifier automatically corrects the polarity. A farad is the unit of capacitance in electronics, named after Michael Faraday. Capacitance is the ability of a component to store electrical charge. A capacitor with a capacitance of 1 farad can store 1 coulomb of charge when 1 volt is applied across its terminals. 1 farad equals 1 million microfarads. This capacitor rated 500 farad, which is equal to 500 million microfarad, which is a very big value. For complete details, visit Top100.com. Today I have used 4 1N4007 diodes to build a full-wave bridge rectifier, not for AC to DC conversion, but to change polarity.